Okay, we're here to do some basic long division, and I know this is really exciting. We have a super hokey little song slash chant. I love coming up with songs or chants to remember concepts. It's really concise, really simple, but we do need explicit instructions to clarify some misconceptions that students may have. So, I am going to sing the chant. I am not the best singer. It's very corny. But here we go. So it goes divide, put your answer on top, multiply back around, subtract, put your answer underneath, then bring it on down. And I would have the kids do motions with this. Divide, where they would be moving their hands like towards, this way, like they were dividing into the house, as we say. And then put your answer on top. And then they would kind of put their arm up, multiply back around. They would move their arms around this way. Subtract, put your answer underneath and bring it on down, and then they bring their arms down. So that is the chant. I will sing it one more time. Divide, put your answer on top, multiply back around, subtract, put your answer underneath and bring it on down. So super simple little chat, but we're going to elaborate some misconceptions that students might have after they memorize that chant. So my students did memorize that chant pretty easily. I was able to sing it like maybe 3-4 times, and then we would sing it like once a day as we were going through long division. And they had it memorized, and they were able to use it to kind of help guide them to solve some of the problems. So here are explicit instructions over here on how to do long division. Basic, not including decimals right now, but you can use this with or without remainders as well. I would encourage people to use their remainder as a fraction as well from a very early age. So we'll talk about that in a minute. So let's say I have 425 divided by 4. 425 divided by, 5. 425 divided by 5. And the dividend, when you have your house, the dividend goes at the end. That's how I remember it, okay? And it can also be written like this or this. 425 divided by 5. So all of those are representing the same problem. So when we start our steps or our song, it says divide, put your answer on top. Now, assuming this is our first time tackling this type of subject, when we divide, we're going to see how many 5s are in 4. That's our first step. We start with our first digit. So how many 5s are in 4? Well, here's 4. There are no 5s. So the answer is 0. So put your answer on top of the digit that it's going into. So since the 5 is going into the 4, or not going into it in this case, you put the 0 above the 4. As we get better, sometimes people learn to skip this step, but we're not going to skip it this time around. So divide, put your answer on top, multiply back around. So the digit we just figured out, we're going to multiply back by 5. We get 0. You place it under the digit that you're dividing into. Line up under the digit that you divided into. Subtract, put your answer underneath and bring it on down. So we're going to subtract 4 minus 0 is 4. And then I'm going to bring down the next digit so that I have a number large enough to divide by. So if you are somebody who can see like, oh, I could have just divided by 42, that's fine. But make sure that when you're doing that, you put the answer to that division problem above the 2 and not the 4. That can harm you when we start to get into decimals. So now I repeat with the new number that was created being divided by the divisor. So my new number created is 42. Now I divide that by 5. So how many 5s are in 42? So we can count by 5, 5, 10, 15, 20, 25, 30, 35, 40. Oh, 45. Oh, that's too many. So it went in 8 times. So now divide, put your answer on top of the last digit that it's going into. So since it's going into 42, the 8 goes above the 2. I'm going to switch colors so that we can see when we multiply around. So now our new digit 8, multiply back around. So we're going to multiply that back around the outside. 8 times 5 now. And we just did that and we got 40. Line up under what you divided into. So I'm going to line it up like this. Subtract, put your answer underneath and bring it on down. So I'm going to subtract. The difference is 2. And I'm going to bring down my next digit of 5. Now, bring down the next digit in the dividend, which is what I just did. And then repeat with the new number created. So our new number is 25. We're going to divide that by 5. Divide, put your answer on top. So 25 divided by 5 is 5. The answer goes on top of this 5 because that's what it's being divided into. And then we're going to multiply back around. 5 times 5 is 25. Make sure that we're lining it up properly. Subtract, put your answer underneath and bring it on down. Well, we have 0 and we have nothing else to bring down, so we have no remainder. So that means our quotient or our answer for this problem is 85. Now let's try one where we have a remainder, and then we can talk about pushing the kids to the next level or pushing yourself to the next level by realizing that the remainder is actually a new numerator and we keep our denominator, which is our outside number. So let me just do a quick erase here. I know that was very pretty and we're sad to see it go. And my singing has quickly deflated into just kind of chanting because I know what I sound like. So sorry about that. Okay, so let's just switch up our color a little bit, get a little something different going on here. And our new problem, let's have 364 divided by 3. So again, we're starting simple, but all of this we can apply to more difficult numbers if we know the steps, okay? Some people say like the dad, mom, sister, brother, divide, multiply, subtract, bring down. So that's another approach that people use to remember. So everything we divide by this number outside the divisor and see how many times it can go into the dividend. So we start with our first digit, which is 3. So we divide, put our answer on top. How many 3s are in 3? Well, here's 3. There's 1 3. 1 3 and 3. So divide, put your answer on top. Multiply back around. Okay? So 1 3 is worth 3. Make sure we're lining it up properly. Make sure we put that 1 above the 3 because that's what it is going into or what it is being divided into. Excuse me. How many 3s are in 3? 1. So we need to put it above the 3. 1 times 3 is 3. Now we subtract, put our answer underneath, and bring it on down. So 3 minus 3 is 0. And I would encourage you, make sure you're lining up really, really well because it's easy to get sloppy and make silly mistakes. And we bring down our very next digit, which is 6. And we have our new problem. Our new problem is this 6 being divided by the 3. So we're always dividing by this outside number here. So I'm asking myself, well, how many 3s are in 6? Well, so now I have 6 dots. How many 3s is that? It's 2. Okay. So divide our new number created, divided by the outside number. Put your answer on top. Multiply back around. So how many 3s are in 6? 2. Since I'm going into 6, I need to put the 2 above it. Multiply back around. 2 3s is 6. We're going to line it up properly, all in a row. Subtract, put your answer underneath, and bring it on down. So now our answer is 0 for this, and I'm going to bring down my next digit, if I have one, which is a 4. And now I have a new problem, so now I start it all over again. So my new number is 4, and I need to divide that by 3. So how many 3s are in 4? Well, there is 1 3 in 4, but I know there's going to be a remainder, okay? And your remainder can never be more than your outside number. That means you did something wrong. So how many 3s are in 4? 4 divided by 3 is 1. Put your answer on top and multiply back around. 1 times 3 is 3. Make sure we're lining up properly. Subtract, put your answer underneath and bring it on down. 4 minus 3 is 1, and I have nothing else to bring down. So that is what is remaining, okay? 3 can go into 364 121 times. but we're going to have one left over. It doesn't go in perfectly. We're going to have this one left over. So I would encourage you to start thinking of that one remainder as your new numerator. Okay? So my quotient is 121, remainder 1, but this 1 becomes your new numerator, and you keep your denominator. You keep 1 out of 3 pieces. It's 1 piece left out of what you wanted, which was 3 pieces. Okay, so it's actually 1/3. It represents 1/3. So our quotient will be 121. Our remainder is our new numerator, and we keep the denominator, which is 3. And we know that this is the denominator because when we originally write this, we say 364 divided by 3.